So we just saw that when we minimized average cost, it turned out that average cost was the same thing as minimum cost at that moment, or at that, say, production level. Why is that? Let's think about what average cost and minimum cost means. And this is going to be another Goldilocks. Let's think for a second. Suppose if average cost is less than marginal cost at a production level. That says that the average price we've paid for all previous items. Remember what A means. This is the average cost paid for previous items. Remember what marginal cost means. We interpret marginal cost as being the cost to make one more item. Or maybe it's the cost of the last item made. It works forwards or backwards. So if average cost is less than marginal cost, that means making one more item, the next item we make, will cost more than average. Average cost of items already made. If I think about all the items that I have made, I've made a bunch of things, they cost an average of $4 a piece. I'm thinking about making one more item. The next one will cost $5. Is that going to help the average, or is that going to hurt the average? Well, I'm throwing in something that's higher than average. And remember, I want my average cost to be as low as possible. So making one more thing will cost more than the others. The next one is a bad deal. And the last one was a bad deal too. Remember, if I want to bring up the average of a group, I need to throw in more things that are above average. If I have a room full of people, throwing in a tall person will increase the average. Removing the tallest person will lower the average. In this case, the last item we just made was also above average. Removing it from the group will lower the average, and we want to lower the average. So the Goldilocks question we're going to be asking is, how do we lower the average cost? We should lower production. And the same thing vice versa. If the average cost is bigger than the marginal cost, then the next item we make, its cost is given by the marginal cost. Marginal cost is the cost of the next item. Average cost is the cost of all previous items on average. The next item we make costs lower than average. It's a good deal. So, to lower the average cost, we should lower production. And if this is Papa Bear and that one's Mama Bear, then Baby Bear is where it's just right. If the average cost equals the marginal cost, then we might be at a minimum. The implication is actually the other direction, that if you're at a minimum, then it must be a critical point. This is the same deal with a critical point, where we basically, this means the thing is a critical point. It doesn't actually mean it's a minimum, but very often, if I'm asking you to find the minimum using this, I'm probably not going to tell you to do the work of verifying that the thing is at a minimum. And that's why, when we minimized average costs, we wound up in a situation where the average cost equals the minimum cost. This has a very beautiful graphical interpretation. Remember what marginal cost means. Marginal cost is the slope of the tangent. And it's measured in dollars per unit. It's always y units divided by x units. Hey, here's a cost function. This is the total cost function. We're not looking at average cost, we're looking at the cost function itself, which is why we're not looking at the minimum. The minimum is always at 0. A cost function should always be an increasing function. Marginal cost is the slope of a tangent line in dollars per unit. Average cost is also in dollars per unit, is also a slope. What is it the slope of? If I'm at a certain production level, I don't know what number this is. Let's make this 50. Let's make this 75. Halfway between 50 and 75 is like 60 something. I don't know, call that 65. I don't really care too much about the numbers. If I'm looking at what's the average cost at a production level of 100, I'm taking the total cost of 100 and dividing it by 100, right? It cost me $65 to make 100 items, so their average cost was 65 cents a piece. This division is a slope, but of what? Well, the 65 is the rise from 0 to 65. That's where the 65 came from. It's that height. The 100 is this distance. When I divide 65 by 100, the thing I am ending up with is this slope. This slope is the average cost. And this is for every average cost you compute. The average cost is always the slope, not of the tangent line, but of the line that goes from 0, 0 to that point on the curve. Well, what does this Goldilocks mean? The Goldilocks says I want to compare the average cost to the marginal cost and see what's bigger. The average cost is the slope of, if I go from 0, 0 straight to that point, the marginal cost is the slope of the tangent line. Let's do this one in blue. I hold up my piece of paper, try and sketch the line. I need a thicker piece of paper. Let's use this clipboard. I hold this up, try and get it at the exact right angle, try and cover up all of the curve except for this one point. There's the marginal cost line. This line's slope is marginal cost. Which of these two lines is steeper? Like I can totally see, the purple line is increasing faster than the blue line because it's going past the curve. The blue line is, not. So yeah, at this point, A is bigger than MC. So to lower average cost, we should increase production. The next one we're making is cheaper than average. It's a good deal. We should make it. We should increase production. We should make more units. The new units are cheaper than average. The really cool thing about this is, if you understand this graphical interpretation, you can look at a graph of costs and see where to minimize average cost.